Hello, and thanks for using TickBoom. For this question, we're asked to find the values of k for which the equation y equals k plus 1x squared minus 2 plus kx plus 3 is positive definite. So the first step to tackling this question is to lay out what it means for it to be positive definite. So we'll say y is equal to k plus 1x squared minus 2 plus kx plus 3. That is positive definite if y is greater than 0 for all x. And it can help to perhaps draw a diagram here of what the curve of y looks like to help us think about the conditions that must be true for us to satisfy this positive definite requirement. So if we just start by looking at what is y when x is 0, so we get 0 squared minus 0 plus 3, so we get 3 as our intercept. Now if this was a concave down parabola, then we wouldn't have y positive for all x, so we effectively need a concave up parabola. That's requirement number 1. But we also need to make sure that the inflection point is not below the x-axis, and that way we'll also make sure that we're always positive for any value of x. And another way to describe that is to say there are no intercepts. So really there's two requirements we need. We need concave up, and we need no x-intercepts. So to find the values of k for y to be positive definite, we just need to see what values of k will let us satisfy both of these requirements. So if I start with requirement 1, in general, we've got the general form of a parabola is y is ax squared plus bx plus c. It will be concave up if a is positive. So all we need to do is say, well, what is a in this format? Well, in our parabola, we've got y is equal to k plus 1 x squared minus 2 plus k x plus 3, which means for us a is equal to k plus 1, b is equal to negative 2 plus k, and c is equal to 3. So that's the parabola we're dealing with. So for a to be greater than 0 means k plus 1 greater than 0, or in other words, k is greater than negative 1. So that's the first thing we know needs to be true. K needs to be greater than negative 1 in order for us to know we're going to have a concave up parabola. Now, the second part I might turn over for this. The second requirement for no intercepts, well, what would the intercepts be? So the intercepts of the parabola would be x is equal to negative b plus or minus the square root of b squared minus 4ac on 2a. That's the general format. And we know that if this part, the discriminant, is negative, then we don't get a solution for our intercepts. So we will have no intercepts when b squared minus 4ac is less than 0. So for us, b for us is minus 2 plus k. So what we need is minus 2 plus k squared minus 4 times a, which is k plus 1, times c, which is 3. That has to be less than 0. Alright, so now we just need to kind of expand this out and work out the values of k where this is true. So we'll get, here we'll get 4 plus 4k plus k squared minus 4 times 3 is 12, so 12k minus 12 has to be less than 0, which means k squared plus 4k minus 12k is minus 8k. 4 minus 12 is minus 8, has to be less than 0. And interestingly now, we've got a new parabola, or quadratic, sorry, in terms of k. So now we need to know, well, when will this be negative? If I just draw over to the side a little diagram. So here we're looking at k, and let's just call it y. We essentially want to know when k is 0, this will be negative 8, so this will intercept at negative 8. We want to know what are these two intercepts, and then between those two intercepts is when this will be negative. So what are the intercepts? Well, we kind of repeat the quadratic formula, this time for k. So here we'll have a is equal to 1, b is equal to negative 8, and c is also equal to negative 8. Therefore, k will be equal to negative b, which is 8, plus or minus root negative 8 squared minus 4 times 1 times negative 8. All of that divided by 2 times 1, which equals 8 plus or minus the square root of, I'll just get my calculator here. So we'll have negative 8 squared is the same as 8 squared, minus 4 times 1 times 8 negative equals 96 on 2. Therefore, we basically want k between 8 minus root 96 on 2 and k between 8 plus root 96 on 2. When k is between those two numbers, we're in this negative territory, and when we're in that negative territory, we'll have no intercepts for our original quadratic. So just to kind of see, well, what are these values? 8 minus the square root of 96 is equal to negative 1.79 divided by 2. So that means negative 0.89897 is less than k, which is less than, and this will just be, well, it'll be plus 8, but I'll just put in the calculator to see. 8 plus square root of 96 divided by 2. 8.89897 and so on. So interestingly, if we kind of just draw up a number line, if I've got maybe that is 0 and k, we knew that k had to be greater than negative 1. So we knew k had to kind of satisfy this. But now we've also got k needing to be kind of greater than negative 0.89 all the way up to, dot, 9, kind of like 8.8. So k needs to be between those 2 points to satisfy our no intercept. So actually the first requirement is almost redundant because it's captured within the second requirement. So we can kind of conclude this question by saying, therefore, y is positive definite when, and I'll just leave it in this format, when k is between 8 minus root 96 on 2 and less than 8 plus root 96 on 2. So that's how I tackle that question. In the end, the key to thinking about it I think that the key to it is drawing up this diagram. That's the way to kind of get you in the right direction, because from there you can kind of deduce that, well, I need it to be concave up and I need no x-intercepts, and that's what then gets you to this first requirement, which actually then gets superseded by this second one, where we can test our discriminant being less than 0. So hopefully you were able to follow along with all of that, and tick boom.